Hello, thank you for joining us today. My name is Eric Zackrell. I'm here with my friend and colleague and boss, Jim Price. And today we're going to talk about IO filters, uh, the gateway to eliminating electromagnetic interference. So our overview today. So we're going to talk about some typical RF filters, um, their characteristics, and then we're going to introduce IO filters and kind of enumerate the differences between a typical filter and an IO filter. And after that, we will start diving into different types of IO filters and their differences, and why you might want one type of IO filter as opposed to another. And we'll go into some use cases, ways that IO filters are used in the industry today. And we'll go through a design example, an integration example, really, of how a customer might use one of these IO filters in their own application. And to wrap it all up, we'll summarize what we've gone over, and as Bailey mentioned, we'll have some time for questions afterward. So, kind of a funny title for this one. Houston, we have a problem. That's not a direct quote from the actual Apollo missions. This is actually the quote from the movie. It was said by Tom Hanks. The actual quote is, Houston, we've had a problem. But be that as it may, the problem statement here is, we have an EMI shielded chamber, and you can have the best chamber in the world, but if you have no way of getting data in or out of that chamber without compromising the integrity of the chamber, that is, then that chamber is really no good than any other closet or warehouse that you might want to do some electromagnetic interference testing or mitigation. So what am I to do? Well, make use of an IO filter. So typical filters, typical RF filters at any rate, they're constructed to pass have a certain pass band and a certain reject band. As you can see in the diagram here, we've got our low pass, high pass, band pass, and band stop filters. And of course, there are many configurations for all of those things. They do not, or they're not able to discern between signals that are desired, that are in that pass band, versus undesired signals in the pass band. So I guess you could sum it up and say the assumption is, when you create the typical filter, everything that you want to go to your system is in the pass band, and everything you don't want is in the stop band. But that's not necessarily the case if you want to send data into and out of your shielded chamber. So that leads us to what are IO filters? Well, they differ from typical RF filters in that they will pass a complex serial data stream, rather than just a carrier, a modulated carrier, or just an audio signal or something of that nature. And when I say complex serial data stream, I'm talking things like USB or Ethernet or HDMI, any of those types of standardized digital serial buses. And for these filters, the data transfer can be bidirectional. So, can go into your shielded chamber or out of your shielded chamber, or both at the same time. And exactly what does it filter out? Well, all wireless signals like your standards, Wi-Fi, Bluetooth, etc., wired signals, and electrical noise. Particularly electrical noise that is generated from things happening in the environment outside of your shielded chamber. And the rejection is bidirectional. So if you have, for instance, a strong signal source inside your shielded chamber that you don't want to escape, these would be effective for that as well, rather than just protecting what's inside your chamber from those things that are outside. And it can provide relief from both conducted and radiated noise. That's important because, once you cut a hole in the chamber, you've effectively nullified the effectiveness of your chamber versus radiated noise. And these filters are very effective in keeping the fidelity of the chamber intact. An additional feature that some filters have is the ability to pass power into the chamber generally, but both ways is also possible. So, types of IO filters, as I kind of alluded to earlier, are common serial buses in use today: USB, Ethernet, HDMI. Other types are possible. It's not to limit us to any particular serial bus. Others could be, developed for specific purposes. If you're a customer, you have a specific purpose that you need a special filter for. Those are possibilities for design opportunities. And there are also power-only types of filters, not really IO filters, but still filters that would be mounted on the exterior of your shielded chamber, those that can pass either AC or DC power or both. So kind of like this slide because it shows a wide array of different IO filter topologies, form factors, performance metrics are possible and are used in the marketplace today. We'll start with passive ones. They typically are smaller in size than active filters. And as the name suggests, they require no external power source. They have some very strong pros in that they do have that small form factor and are able to be used in a small space. Now their performance may not be as excellent as an active filter, but engineering is always a trade-off. You give up one thing and get another. So if absolute performance is not critical to you, a passive filter may be the solution for you, particularly if you don't have a power source available. Now, the isolation on the passive filters is typically achieved through a low pass filter, although sometimes a band pass filter can also be used, with some added complexity. And active filters, on the other hand, do require an exterior power source. They typically have much better performance specs than a passive filter. And we'll get into that a little later as to what kind of specs we can achieve between our passive and active filters. But the key thing with the active filters is they can reject the same noise in the same frequency spectrum as the serial bus itself. So that's very critical because at the higher data rates for your serial bus, think of maybe 10 gigabit Ethernet, something of that data rate. You may very well have a cellular carrier in that very same band that you want to block, or some other radio signal. And so the active filters excel in that performance metric. The passive filters, not so much. And something else to consider with the active filter versus the passive. A passive filter can load down the serial bus. What do I mean by load down? I'm talking about decreasing the reach, the length of your bus. USB in particular, if you want to be able to send high data rates, your cables must be short. Whereas an active filter acts as kind of a repeater. So you can get a longer cable reach if you use that active filter as opposed to a passive one. So IO filter performance. As I mentioned earlier, Quantic Cori does offer some IO filter offerings, and this is just a slide that does a little comparison of actually 3 of our Ethernet filters, 3 of our Ethernet IO filter offerings. First one, so we have two different active filters that we offer and a passive filter. So you can see that our active filter is able to achieve 100 dB of rejection from 10 kilohertz to 18 gig using the PoE pass-through option. And then our filter with a PoE injector as one of the options has also 100 dB rejection, but this is from 1 megahertz to 18 gigahertz. And you might wonder, why the difference there, and it mostly comes to size of filters and practicality. It's filtering the power with the PoE injector is a little more space intensive, I guess you might say. And then, so on the PoE pass-through option, we offer 50 volts DC at 2 amps, so 100 watts. That's a pretty healthy amount of power. And then our internal PoE injector option supplies 48 volts DC at 1.25 amps. So that's 60 watts of power. And, data rates achievable, all of your various standard data rates from, 10 megabits up to 10 gigabits per second. Whereas our passive offering, it only has an 80 dB rejection, and that's typical. Some regions it's better, but we'll guarantee 80 dB. But that's, this is a low pass configuration, so that rejection is only good from 500 megahertz to 18 gigahertz. If you dip below 500 megahertz, well, you're not going to get 80 dB because the low pass filter response has a 3 dB cutoff frequency of 275 megahertz, and while the low pass filter has a very steep drop off, it's still not a brick wall. So you're going to have some degradation in filter effectiveness over that range. And then under 275 megahertz, there's virtually no filtering. But it does do a PoE pass through at 100 watts and doing your typical 10, 100 and 1 gig data rates. So where might I use an IO filter? Or why might I use an IO filter? What applications? Well, I've already mentioned that these are to be used in conjunction with a shielded chamber, EMI chamber, anechoic chamber, and it doesn't matter whether it's a 10 by 20 room or whether it's a 1 foot by 2 foot by 18-inch box. The IO filter is equally effective regardless of the size of the chamber. And these are typically used for wireless R&D, for component design, system integration, software verification, production testing, compliance testing, and one interesting application is digital forensics. Law enforcement making use of a shielded chamber to carry around evidence that's of a wireless nature. And then anywhere else that electromagnetic interference mitigation might be needed, maybe a large data center, maybe probably not in your own home, but in possibly a large mill production setting, industrial, where lots of blast furnaces and things, or variable frequency drives, all those things that just spray electromagnetic interference into the air. If you want to protect some sensors or a server room, something of that nature, these filters could come in handy for you. So here I've got a little use case diagram. It's kind of cartoonish, excuse me for that, but I think it gets its point across rather nicely. On the right-hand side, we've got this shielded chamber, and you can see a mini IO filter there attached to the side that happens to be one of our USB-C IO filters. And on the outside of the chamber would be a PC or something else that would provide host connectivity to the device under test inside the EMI chamber. And these the filter mounting and everything is important, and the way that you cut the holes into the chamber and mount the filter, and not to compromise the integrity of your chamber, all of that stuff is very important. And there are specific best practices for doing so. And so let's go down to a current IO filter application. So think of an operating room with lots of surgical instruments inside. Think of imaging sensors, MRI, CAT scan, things of that nature inside the surgical theater that doctors will use while their patient is on the operating room table in order to visualize the body and where their instruments are in relation to the things they need to gain access to in order to have a successful outcome for the surgery. And one large application or one prime example of this is digital Ethernet filters. The power over Ethernet capability is very important because having a clean power supply inside of the operating room is not always an easy thing to accomplish. The noise from a power supply itself can show up on the imaging equipment and can cause the picture fidelity to be not as crisp or clear, and therefore compromising the outcome of the patient, and nobody wants that. And so it's a very good example of just how these IO filters might be used or are being used today.
Yeah, and getting back to the Type C example, you could put a cell phone inside a shielded room and isolate it from nearby cell towers, yet still be able to communicate with it over its Type C interface to a host computer.
It's a good segue. We have another IO filter example. So let's if we will take the need of law enforcement. They will often confiscate a suspect's electronic devices, thinking there may be evidence on them of illicit activities, and so they'll want to get that device away from anyone who can access it as quickly as possible. So, in this example, law enforcement would want to be able to access the device themselves, but not let the perpetrators or suspects or any of their other actors working in conjunction with them be able to access the device and possibly wipe crucial data from it before they've had a chance to gain evidence. So, kind of the requirements for this would be able to provide power to the device to keep it from powering down and therefore locking the screen and them losing access, prevent the device from accessing any wireless network, because as you know, nowadays there are remote commands available to wipe your devices, and it allows for law enforcement to pull evidence from the data inside the box. You can see a picture of this box is actually got a little viewing window on the top, and holes for hands to go inside, and those so this is a benchtop type chamber. Sorry if the size is not clearly evident. There's no dimensions in the picture, but this is a benchtop device, and it allows the police or FBI or whomever to both see and touch the device and have a data port access to it. And a great example of a filter that would be useful in this case is a USB-C Type C filter, IO filter, as it has both USB 2.0 and 3.1 compatibility, ability to power the cell phone or other wireless device, and unlike the old Type B plugs, you could quickly plug it in and get that lid closed, and oftentimes speed is of necessity, so it just makes good sense.
Yeah, most cell phones have a little Type C connector at their base that you use for fast charging the phone. It's not just a charging interface, it's a data interface that you transfer files from the phone and a host computer. You can communicate and control the phone from a host computer over that interface. IO filter would allow you to do that in an isolated way.
So next slide, please. So here's our summary slide. So our IO filters are used for common serial bus types. They pass serial bus traffic in both directions and can block all other noise sources. As I mentioned, the active filters particularly excel in this regard. And IO filters are made for use with shielded enclosures. Without a shielded enclosure, you're not going to get the most out of your IO filter. And also the different grades of filtration exist. The active filters tend to perform a little better, but at a higher monetary cost, as well as power budget costs and potentially size cost. But the passive filters, they're really great for compact installations and are cost-effective solutions for many applications, particularly those where the bands that are of interest are outside of the serial bus bandwidth. And additional features such as power delivery or power pass-through are also available on the IO filters. So this is just a little blurb about Quantic Cori. We are very skilled in EMC design and compliance. We have a strong line of IO filter products, as well as other RF filters, diplexers, triplexers, many other RF subsystem building blocks. And whatever your requirement may be, we will partner with you. We can take your specifications and turn it into a product that we believe that no one else can outperform. We pride ourselves on really satisfying customer requirements and customer satisfaction. And we'll work closely with your design team, throughout the design process, as sometimes specifications change, design scope changes, and that's part of the engineering design process, and we understand that. And so we'll walk hand in hand with you to fulfill whatever requirements you or your customers might have. And some relevant standards that you may encounter in regards to IO filters and EMC compliance. I'm not going to list off the alphabet soup below, but there's a small list for you. And finally, we're on to our question and answer segment. So
thanks, Eric. So if anybody has any questions, please feel free to enter them using the chat or Q&A buttons. I did have a couple that came in throughout. First one, you mentioned pass-through power and power delivery to provide power to a device from the IO filter. Are those the same? And if not, what is the difference?
Well, they are not the same. Yeah, I'm sorry I didn't address this more explicitly. So what we term power pass-through, if you think about your typical serial bus USB, for instance, if you plug it into a host device, and you want to power a device, it draws power directly from the host. And so that would be a power pass-through type of application where the host device actually sends the power through the filter to the device requiring it. Whereas what we term power delivery is the filter is delivering the power to the device and not the host. So in case of power over Ethernet, we have both a pass-through option and a PoE injector option. So those are two separate things. The PoE power delivery option has a filtered power supply inside it, as well as a PoE injector circuitry as well.
Yeah, typically the way these protocols work is the end device that could be maybe an internet camera or something like that, could be tied to Ethernet. It could indicate to the host that it wants power without actually receiving any power yet. When you plug an end device like that in, it can indicate it doesn't need power to indicate that it wants power, and the host device, which is usually powered, can detect that fact and then can negotiate with the end device, such as a camera, for example, and ask it, well, how much power do you need? What type of power? That kind of thing. And they can work that all out, and that would be a pass-through application. Or we allow that to happen in a filtered way through the device. Ultimately, we can be the negotiator. We can cut out the host, and we can provide the power and negotiate with the end device. And that's different. The different circumstance Eric is bringing up.
Okay, great. Thank you. Another question. So when shopping for an IO filter, what criteria should I focus on?
Okay, well, first and foremost, you're going to have to determine what serial bus type you require. That one's kind of obvious. Do you require any sort of power delivery? If you do, then it should be capable of either passing through that power or sourcing it itself. But maybe the most critical is the filter stop band. If you have a particular band that you need to reject that is causing you problems, then choosing an active filter would probably be your best bet, as it only passes the serial bus stream that you need. But if you know exactly the spectrum, the frequency spectrum of signals you want to reject, a passive filter could be equally effective for you. Just need to know that if that signal that you want to reject is within the pass band of the passive filter, that it's not going to be the right choice for you. And then the last major point criteria, I would say, is your data rate needs. And that kind of goes hand in hand with your bus length as well, because as your bus length gets longer, the data rate typically can't keep up. Active filters are going to give you generally higher data rates, capability of higher data rates, and extending the bus longer as well. So hope that answers your question.
Great. Next question. I want to communicate to a device in my shielded chamber that uses a proprietary RS-232 serial protocol. Is there an IO filter for that?
Well, I'm going to give you a short answer and a long answer. The short answer is no, we don't have one right now. But and here's the long answer part. The passive filters that are out on the market, and ours are no exception to this, are able to pass a variety of signals as long as they are within the pass band of the filter itself. An active filter will not allow such kind of double usage, but a passive filter can perform this kind of operation. So if, in this particular case, if you were to try a passive Ethernet filter, it's very likely that your RS-232 signal would pass directly through, and you would be successful using it. Now, if you were to try it out in your application and find that it does cause signal integrity issues, something of that nature, an alternative would be to use some kind of a data converter, like an RS-232 to USB, and then USB back to RS-232, and then utilize one of our standard filters, or filter from any other manufacturer for that matter, although we hope that you choose ours.
That brought up another good question. Can I use more than one IO filter at a time?
Certainly, yes. And that is a very, very common use case. We know of many customers that have 30 or more IO filters on a chamber, and they just have a multiplicity of connectivity options, and they the bandwidth needs in and out of their shielded chamber are high. So yeah.
Okay. What's the process for installing an IO filter on a shielded chamber?
Ooh, well, the integrity of the chamber is what's most important. So any hole that you cut in the chamber is going to compromise that. So being able to plug the hole essentially is what you need to do. And the form factor of the IO filter plays a role in that. Many filters will either have a threaded pipe or a screw-on type of connection to a metal plate, to a flat plate, and using some EMI gasketing, you can cut a hole in your chamber and successfully seal it up. What many customers do is they will cut a hole large enough to essentially machine a large plate and put many bolts in it in order to minimize EMI leakage, and then cut holes for the EMI filters that they want in that plate. And then it becomes kind of a modular solution where they can swap filters in and out, change the plate in and out, and do things of that nature.
Okay. I have one more question here. What power supply do active filters need?
Well, I'm only going to speak for Quantic Cori on this one, but for our active filters, any commercial off-the-shelf AC to DC converter is going to be suitable, as long as it does satisfy the power requirements that we have called out. So, for instance, if the filter requires a 60-watt power supply, as long as you provide a 60-watt power supply at the right voltage, it should work with your filter just fine. We do have our own recommended supplies. So, if you're questioning whether, if there's any doubt in your mind as to whether you can choose a proper power supply, we have one that we can provide and make sure that nothing is compromised.
Yeah, that's a great note to end on. Eric and Jim, thank you for that. And thanks everyone for submitting your questions. If there are additional follow-up questions, I encourage everybody to reach out to Eric or Jim. Contact Quantic Cori via quanticcori.com.